Our oceans cover about 70% of the Earth's surface, but to what degree do we really understand them? Measurements taken in the water provide us with a wealth of information, and hundreds of kilometres above the ocean surface, satellites are making their own measurements, giving us a broader view of these vast bodies of water and revolutionising oceanography. We know that oceans have a major impact on the weather and the environment, acting as heaters at the poles and air conditioners at the equator. A global conveyor belt of ocean circulation is responsible for the transport of heat, carrying warm water from the equator towards the poles. There is more life in the oceans than anywhere else on Earth. One of the smallest forms of ocean life, but one of the most important, is plankton. In addition to being a source of food for other aquatic life, plankton produce oxygen while soaking up huge amounts of carbon dioxide. Increasing sea surface temperatures and sea level rise are becoming an observable reality in our oceans. Understanding them has become one of the most important factors for measuring and predicting environmental change. Satellites are one of the most effective ways of monitoring these changes in our oceans from different perspectives.
In the context of climate change, again, the oceans are the greatest reservoir of the anthropogenic, if we put it that way, the excess heat that our planet is accumulating. And the satellites help us to see how at least at the surface, how the temperature is changing.
ESA's Earth observation satellites have been monitoring oceans for years. On board the ENVISAT satellite, an infrared radiometer measured sea surface temperature to within a fraction of a degree. Cryosat, ESA's ice mission, is dedicated to precise monitoring of the changes in the thickness of marine ice floating in the polar oceans. The Soil Moisture and Ocean Salinity satellite, called SMOS, and the Gravity and Ocean Circulation mission, called GOCE, are also providing us with information to help us understand ocean dynamics and their relationship to climate. Oceanography with satellites will take a leap forward with the upcoming Sentinel-3 mission being developed for Europe's Copernicus program. Sentinel-3 is based on a constellation of two identical satellites orbiting 180 degrees apart and will provide global coverage every 1 to 2 days.
When you travel across an ocean from the North Pole to the South Pole with a satellite, it takes 50 minutes, and 50 minutes to complete the circle. Given that we'll be doing 14 orbits a day, you have global coverage in practically 1 day, something that would perhaps take a year by boat.
Carrying a suite of state-of-the-art instruments, Sentinel-3 will measure the topography and temperature of the sea surface.
We measure the level of the sea, which rises by 3 millimeters a year with a precision of a fraction, say 0.4 or 0.3 millimeters a year. We are working on improving this set of measurements and will now prepare for the integration of the new satellite Sentinel-3.
Sentinel-3 will also measure ocean colour, an indicator of the levels of those microscopic phytoplankton responsible for producing half the oxygen on Earth.
They will respond very, very rapidly to any change. So probing the phytoplankton population is one way to understand how the ocean ecosystem, which is at the mercy of the physics of the ocean, how they are responding to climate variability and eventually to climate change.
We've long known that oceans are integral to all known life and govern our weather and climate. By combining information from an array of satellites with continued ground-based measurements, we get a global perspective to help us further understand our oceans.